Okay, this is the second video for 2.8, and we're still working on using the rational zero theorem to solve some polynomial equations. So we're looking at number 7, and I'm going to do this with you, and you'll see where you're. I don't know if one of these will factor, so we look and we can't do factor by grouping, obviously, with that 29 sitting there. So okay, so let's do P over Q. So P is equal to 15. So that's plus or minus, well, let's just not write the plus or minuses yet. We'll do that when we do P over Q, sorry. Okay, so 1, 3, 5, 15. And Q is equal to just 1. So P over Q, the possibilities, would be plus or minus 1, plus or minus 3 over 1. These are all over 1, but, I'm just not putting the over 1. Plus or minus 5 and plus or minus 15. So those are our choices to try. So I always say try 1 and negative 1 first. So 1 gives me 1, negative 5, negative 29, negative 15. So 1 times 1 is 1. So put a 1 there. That would be minus 4. So minus 4 would be negative 33. And so that would be negative 33. So 1 doesn't work. Let's try negative 1. Okay, so negative 1 is negative 5, negative 29, negative 15. 1 times 1 is 1. Negative 1, negative 6, that would be positive 6. So that would be 25. And that's not going to work either. So no to 1 and negative 1. Oops, 1 and negative 1. Now I'm on 3 and negative 3. So I'm going to go down here. 3, 1, negative 5, negative 29, negative 15. 1, that would be 3. So I'm at negative 2, negative 6. That's a negative 35. So does that work? Nope. Try negative 3. Okay. 1, negative 5, negative 29, negative 15. So that's 1, negative 3, negative 8, positive 24. And that would give me negative 5. And there's a positive 15. Yay, I found one. So negative 3 is it's going to be a 0. So this reduces to x squared minus 8x minus 5. And so I have that, and I have x minus 3. All right, now I kind of know this is going to give me a 3, and I'm in irrationals in this text part of the textbook. So is this factor? Can you think of anything that adds up to 5? That multiplies to 5, which is only 5 and 1, that would add to negative 8. So this does not factor, so you're going to have to use the quadratic formula or completing the square. And I like completing the square with this one because it doesn't have an a term, and 8's an easy number to divide by 2. So try to remember how to complete the square. If you don't know how, you need to look this up. So it would be, let's see, x squared minus 8x plus what makes a perfect square. And then keep the minus 5, and you have to, you're going to have to take away what you just added. So I added this. I'm making this up. This was the rest of the trinomial. And so then I have to take that box away, whatever I had. So I'm just going to add something and take it right away over here. But this part's going to be a perfect square. So how do I remember how to do a complete the square, you divide this one by 2. So that's 4. And 4 squared is what goes up there. So this would be plus 16. And then I have to take away 16 to keep it correct, to keep it all even. I didn't do anything. I added 16 and took 16 away. But it let me make this perfect square, x minus 4 squared. This stuff right here makes this perfect square. And you'll see why I wanted to do that in a second. Now this would be, got to add this together, minus 21. So I completed the square. So now I can set this whole thing equal to 0. So I get x minus 4 squared equals 21. Take the square root of x minus 4 squared and the square root of 21, but I have to do plus or minus. And I get x minus 4 equals plus or minus the square root of 21. So x is 4 plus or minus the square root of 21. Now, I'm going to go to the next slide, see if I can add a slide in here. Shoot, let's see. Trying to remember, how do I get some space? Let's see, I know. I'm going to erase this side because none of those work, so I'll get some space back. Okay? So, space back here. Okay, so I'm at x equals 4 plus or minus the square root of 21, and 21 you can't simplify, so that's going to be one root, and the other root was just this guy way over here that he was okay the way he was, so that would be 3. So x equals 4 plus or minus the square root of 21 and positive 3. Almost kind of crazy. Is it positive 3 or negative 3? It should have been, because I took out negative 3, that's the one that worked way back. This should have been a plus 3, so fix that in your notes. Sorry. So here's the right answer. Now the other ones I've done and taken a picture of, so you can, if you want to do some more of these and try them, go ahead and look at these answers. So number 8, 1 worked right away, so that was good. So then this polynomial became x squared plus 6x minus 19, and that doesn't factor. So using, instead of completing the square this time, using the quadratic formula. So learn that, remember that quadratic formula if you forgot. So giving you those 2 zeros. And there was a lot of possibilities for this guy, and unfortunately it was all the way to negative 4 that worked. So this should be, if it ran off, the answer should be negative 4 and 3 plus or minus 3 square root of 5 all over 2. So that's what x equals there. And the last one, if you try that one, is 6 and 6 plus or minus the square of 39 over 3. All right, so you should be pretty, if you've done these and you understand them, you should be pretty well able to solve polynomials using the rational zero theorem. Unfortunately, it's hard to check all those. It takes a long time to find one sometimes. Like this one, I was all the way to 6, so you had to try all that. So the next thing I'm going to show you in the next video is a way to eliminate some of the choices. To make, you still have to use P over Q, but what if we could decide, okay, I only need a few of P over Q. So check out the next video, and I'll see you there.